In this lesson, we're going to look at something called standard form or scientific notation. Now, scientific notation is a way of writing very large or small numbers and is often used both in maths and in science, hence scientific notation. Now, the reason behind using this method of notation is because in mathematics, or in science for that matter, writing really large numbers and doing calculations with really large numbers is sometimes very clumsy. So we need a better way of writing these, a shorter method of writing, and this is what scientific notation is. Very large numbers here, if you're talking about distances between planets and things like this, you generate huge numbers. I mean, the distance between Earth and Mercury is 77 million kilometres. Again, from Earth to Saturn, there we are, 1,517,000,000 kilometres, and between Earth and Uranus, try not to laugh too much, we have 1,774,200,000. This is your billions, your millions, and your hundreds of thousands. So we need a better way of writing these instead of writing loads of zeros on the page. Again, dinosaurs, they were around 230 million years ago. Time can also be a place where you get loads of zeros. And calculations like this, like how many seconds in a year, would also provide very large numbers. And just incidentally, to do this, 1 year you would think, okay, how many days are there in a year? 365. How many hours are in a day? 24. So 365 times 24 will get you the number of hours. Then how many minutes in an hour? 60, so times that by 60. You'll get so many minutes. And finally 60 seconds in a minute, so do the same thing, times this number here by 60. Again, you generate a really big number of seconds in a year. That would be 31,536,000. So let's look at how we can write really large numbers in a compact or smaller way. And the way to do this is to use powers. You've seen powers before. Now we can rewrite 10 as 10 to the power 1. 100 can be shortened down to 10 times 10. We should know that means 10 squared. Or we can rewrite it as 10 squared. 1,000 can be written as 10 times 10 times 10. That can be said to be 10 cubed. And this process continues and continues. 10,000 can be written as 10 times 10 times 10 times 10. We could shorten that down to 10 to the power of 4. And 100,000, you're going to have 5 tens multiplied together, so that's the same as 10 to the power of 5. So instantly we've got a shorter way of writing numbers with lots of zeros after them. This is long here, this is very short. Okay, so let's try and apply it to something more than 100 or 1,000 or 1 billion or whatever. Now the way to do this is, instead of writing 300, we can write 3 times 100. But that's the same as writing 3 times 10 squared. And this is very much the idea behind scientific notation, this idea of taking a number and multiplying it by 10 to the power of something. Same idea here, we can rewrite this as 4 times something. So 4,000 is 4 times 1,000. And we can shorten the 1,000 down to 4 times 10 to the power of 3. We've got 70,000 here, we can write that as 7 times 10 to the power, so 7 times 10,000, which is 7 times 10 to the power of 1, 2, 3, 4, because there's 4 zeros in the end. We've got 9 here, times 100,000. That's got 5 zeros on it, so it's 9 times 10 to the power of 5. And all that's going to change here is this digit here. The power value for the 10, as the numbers get bigger and more zeros go on, you just change this number here. So this one would be 2 times 1 million, because it's got 6 zeros. 1 million's got 6 zeros. So that's 2 times 10 to the power 6. Okay, I'm going to look at this in more depth in the next video.